In this video, I'm going to be looking at Snell's law. Now, up till now, we've looked at the fact that if light travels from a more dense medium to a less dense medium, the light ray will bend away from the normal. And if it travels from a less dense medium to a more dense medium, it will bend or be refracted towards the normal. What we haven't looked at is exactly how much it will be bent or refracted towards or away from the normal. Snell's law now allows us to take this idea or concept of it getting bent towards or away from the normal and actually calculate the angle of refraction that you'll get depending on the angle of incidence. Snell's law of refraction states that in passing from one material to another, the ray of light is refracted at the boundary according to the equation. Eta 1, which is the refractive index of the incident medium, times by sine of theta 1, which is the angle of incidence, will equal eta 2, which is the refractive index of the medium that you're moving into, multiplied by sine of theta 2, which is your angle of refraction. Basically, if we look at this on a diagram, your refractive index of your first medium is the medium that you're moving from. So in this case, if we were to imagine that this is air into glass, this over here is the refractive index of the air. Sine theta 1 is your angle of incidence over there. Your refractive index 2 is the medium that you're moving into. So over here, we're actually only considering the interchange over here, not necessarily when we're leaving over there. That would result in a separate set of equations. And our theta 2 is going to be this angle here, which is our angle of refraction. It's very important that you realize that 1 refers to everything in the first medium, which is the medium you are moving from or you are leaving. And 2 refers to everything that the ray will want to enter, or in the medium that the ray will want to enter. So this is the medium you're moving to. If you muddle these two up, obviously your angles will change, because you'll notice if you're moving from the more dense medium to the less dense medium, your rays would go in opposite directions. So to explain this, I'm going to quickly do one example, only one. Then you're going to be answering a couple of think tanks and exercises to cement the idea, and watch in between videos to ensure that you're getting the idea right. Question says, use Snell's law to determine the angle of refraction if light is traveling from air. I like to draw pictures. You've worked this out by now. So I've got my air over there with its refractive index of 1,00029. Into water, we've got water over here with a refractive index of 1.33. Now this particular ray is going to strike the water at an incident angle of 30 degrees. So here we're going from the air into water. This angle here is 30 degrees. Now we should know already here we're going from air into water, hence we're going from less dense to more dense, so this should bend towards the normal, which means our angle that we get out should be smaller than 30, but we don't know exactly what it's going to be. The equation that we're going to use is Snell's law, which is given over here. So, hence we would go and say the refractive index of medium 1 is 1,00029. That's the medium that we're moving from. Then we're going to have sine, our theta 1 is 30 degrees. It is essential that you do the angle between the ray and the normal. If you go and put in this silly angle here, you're going to get it wrong, so please don't. That will equal our refractive index 2, which is 1.33, times by sine of our refracted angle, which we can just call r hat if we want to. So if I put in 1.00029 times sine of 30, I get an answer that looks about 0.500145. I'm going to divide that by 1.33. From that, I calculate that sine of my refracted angle is 0.376. It is not important that you show this in between step. I'm just gauging it so that everybody can follow me. Now, please note, I keep the full value, 0.376048872 on my calculator. I then am going to do arc sine to get this angle by itself. To do arc sine, remember, it's your second function or your shift of sine. So if I do arc sine angle, I end up getting that the angle itself is 22,089 degrees. Please note you don't need that many decimal places. You're quite it's quite acceptable for you to do 22,09 degrees. Now, if you were to look at this being 22,09 degrees fits what we've already learnt. We've learnt that it bends towards the normal. If it had gone straight through, that angle would have been 30. Since this is smaller than 30, it makes sense. Please always check that your angles make sense in terms of which way they should bend and how big their values should be. Please, once you've completed this video, you're going to go and do the next think tank. Only watch the video with the solutions after you have completed all of the exercises.